is laminar or turbulent. So how do you check with the laminar or turbulent in case of an axial convection? Somebody tell me, how do you check for laminar or turbulent case in case of natural convection? We will
Grasha.
make use of the Grashof into Prandtl. Yeah, the Grashof into Prandtl we will make use of, and Grashof into Prandtl is less than 10 to the power of 9. That is laminar, otherwise turbulent kind of thing. So here we have to find out what is called as a Grashof number. What is the formula for Grashof number? Somebody speak out. See, if you forget the formula for Grashof number, that is also available in page number 120. Okay, if you refer to your data book, it will be there. Refer to page number 120. Okay, the Grashof number formula is available there. Okay, so it's given in dynamic viscosity terms here, but I'll take it in kinematic viscosity terms by removing this rho term here. Okay, so please remember this page number 120. Okay, whenever you forget a formula for the given dimensionless number, you can definitely come to this page number 120 in the data book and remember it properly and then write it. So anyways, here the Grashof number formula is G beta delta T into L cube by nu square. This is the formula. So in this, what is G? G is acceleration due to gravity, 9.81 meter per second square. What is beta? Beta is 1 by TF. Okay. What is TF here? In case of free convection, the TF is the temperature where all the properties are to be evaluated. Okay, all the properties are to be evaluated at TF. Okay, so what you will do, you have to write the value of TF actually. So the TF is equal to T wall plus T infinity by 2. It is 90 plus, what is the other one? 30 by 2. What is this value? 120 by 2, which is 60 degrees centigrade. So all these values, all the properties are to be evaluated at 60 degrees centigrade. That's what you would take from the data book. So 1 by TF here is 1 by 60 plus 273. Okay. Very important thing to remember in this regard is this TF should be taken in Kelvin. This TF should not be taken in degrees centigrade because you are taking only one value. The SI unit for temperature is Kelvin, so that's when I have to take here. And the delta T is T wall minus T infinity, which is equal to 90 minus 30, which is 60 degrees centigrade, or 60 Kelvin also. 60 degrees centigrade is equal to 60 Kelvin here because plus 273, 90 plus 273 minus 30 plus 273 again will give you the same value for delta T. Okay, so right, that's the story of delta T. Let's move to the story of L. What should be the L here? L is this one. L is 0.6 meters. L is 0.6 meters. That is given. We are done with L. And the numerator, you have new. It is to be found out from the data book. Okay. So for that, you have to move to the properties of air page. Where do you have properties of air? What is the page number? Tell me.
42.
Page number 42. You will have the properties of air. So here it is. Page number 42. Move to page 60 degrees thing. There you will have the kinematic viscosity. Here it is 18.97 into 10 to the power of minus 6. This is a kinematic viscosity I am referring. 18.97. 18.97 into 10 to the power of minus 6 meters square per second is your new value. From the data book, the new is found to be 18.97 into 10 to the power of minus 6 meters square per second. So you have all the values with you here. You can find out the Grashof value. So substitute them. G 9.81. Beta is 1 by 60 plus 273 plus delta T into the delta T is 60 into the L cube 0.6 whole cube G beta delta T into L cube by nu square. The nu square is 18.97 into 10 to the power of minus 6 whole square. So that is your Grashof. Tell me what is the Grashof value?
106
106
095
095
0480.
0480. This is the Grashof number value. And what you need is actually Grashof into Prandtl. Okay. So how do you get the Prandtl value? You have to go to the data book. So in the data book at 60, what is the Prandtl value? You write it. 0.6. 0.696 is the value. So substitute that here 0.696. Actually, you got it from data book. You got to write the page number also 0.696 is the Prandtl number value. Now you multiply the Grashof with Prandtl and tell me what is the value directly.
0.738 into 10 power 9. 738.
0.738 into 10 to the power of 9. That is equal to 7.38 into 10 to the power of 8. It is 10 to the power of 8 only. It didn't reach the 10 to the power of 9. So the Grashof into Prandtl is less than 10 to the power of 9. Okay, so that will imply the flow is laminar. The flow is laminar, and then you can use the appropriate formula from the free convection formulas for NU. We have this formula, this one, this one, this one, and in laminar case, we have a few more formulas here. This one we have, this one we have, and this one you have. Okay, so anyone you can use. These two are generally used things. Okay, these two are generally used things. I think we must have it here. Anyways, so these two are generally used things. Uh, this is a easy one, the first one. You can actually by heart this value also for competitive examination purpose. It's better to remember this formula also. Anyways, now we can use any one of these two formulas. Okay. So here, by using the second one, you have to make sure about this one here. Okay, if you are using constant wall temperature, you can use the formula as it is. But if you are using for constant heat flux, in place of 492, you have to have 437. That is the only difference here. Otherwise, both are almost same. So let us use both the things and solve the problem here. The first one here is Nu bar, which is equal to 0.59 into Krashoff into Prandtl whole to the power of zero point 0.5. This is the formula. So this is equal to 0.59 into 7.38 into 10 to the power of 8 whole to the power of 0.25. Tell me what is this Nu bar?
172.92.
1.72 point
92.
0.92. That is a new bar value. So from this you will get H value. So HL by K you have to take here 172.92. The H is unknown here. The H into the L value is 0.6. The K value is again unknown. You have to get it from the data book. So move to data book, page number 42. You will have K value 0.02896. 0.02896 watt per meter Kelvin actually 172.92. Tell me what is the H value now?
So that is 97.2, sir. Nusselt.
H result itself is wrong. Huh?
Yes, sir. Small mistake.
Yeah. Others also cross check. 97 is correct. Huh?
2.
97.2.
H 4.69.
H 4.69 watt per meter square Kelvin. So you can get Q also. Q is equal to H into A into T wall minus T infinity. So this is equal to the H is 4.69 into A. What is the A value? It is 0.6 into 0.6 given in question. The T wall is given as 90 in question. Infinity is given as 30. So tell me what is the Q value? Yes, please tell me what. 1 not
101.39 watts.
101.39 watts. Okay. So this is what he has asked you in the question. Apart from this, H is also important thing. NU also is an important thing. So put all of them in box for evaluator. It will be very clear. Right. So that is how you will find out the H value using the first correlation I told you. You can also use the second correlation. Okay, let us use that also to solve this problem so that you'll get a clarity. So the second correlation I told you is this one. So the NU is equal to 0.825. It's a bit complex compared to the previous one, but nothing seriously great. The shaft into panel power 0.167. 5 1 plus 0.492 random random to the power 0.5625 whole power 0.292 and to the whole square. So that's what your Nusselt formula is. Now tell me what is the Nusselt by substituting all of them. 0.825 plus 0.387 into the Grashaff into Prandtl is found out here. What is that? 7.38. 7.38 into 10 to the power of 8. How to power 0.167 by 1 plus 0.492 by the Prandtl is Prandtl is 0.696. 0.696 to the power 0.5625 whole to the power 0.292 whole square. So tell me what is the Nusselt number value here?
113.04.
113.04 is your Nusselt number value. And once you know the Nusselt number value, what is the next thing to do? You can find out the H value. HL by K is equal to 113.04. So H into 0.6 by the K value we have taken from the data book 0.2896, which is equal to 113.04. From this, tell me what is the value of H.
54.79.
54,
5.45.
5.45 watt per meter square Kelvin. Okay. See, when you look at these values, both are almost same. Okay. The H value also won't vary a lot. Okay. Pawan, switch off your mic, please. Uh, so the Nusselt value is almost close. This is 100, this is 113, this is 5, this is 4. So no much variation. They are almost close. So that's what I would like to convey by solving using both correlations. Like any correlation, is Q is equal to H into A into T wall minus T infinity. And that is equal to 5.45 into 0.6 into 0.6 into the T wall is 90 and the T infinity is 30. So Q value also you can
117.72.
117.72 watts. So it's also almost close to the Q value that you got previously. Okay, both ways it is correct. So you're done with question number A. Basically, what we have done so far is for question number A. Now we have to solve for question number B and question number C. In question number B, you have horizontal surface facing up and horizontal surface facing down is question number C. For these two things, we have formula in the data book. So, the vertical case is the most general case, I'm telling you. Okay. Most of the times questions are given based on the vertical case. For the sake of completeness, I'm telling you horizontal also. So Here you have a horizontal plate. Okay. This horizontal plate problem is given here. And in horizontal case, the upper surface heated or lower surface cooled kind of examples. Okay. This is a constant wall temperature case. Again, ours is a constant wall temperature case. So you can choose the formula from any one of these things. See, here the Grashof into Prandtl range is given. Based on that, we can choose. But the difference here is here L value. Okay, whatever the L you take in Grashof is not the L that you are going to use previously. Okay, previously we are actually using the length along which the boundary layer is formed. But in case of horizontal plate, L is given as area by perimeter. Okay, so what to do is in case of horizontal, question number B, horizontal. What is this page number? Refer to the page number. It is 144, 2.1.1. 144, 2.1. So if you look at there the L is given as 4, no, it's not 4. What is that? Area by perimeter. A by perimeter. So what is area here? It is 0.6 into 0.6. Okay, what will be the perimeter? It's a square plate like this. So when you have a square plate like this, you have 1, 2, 3, 4 sides, and all are 0.6 only. So 4 into 0.6 will be your perimeter. So 0.6 by 4, somebody tell me what is the value? 64 parts. If you make it is 15, 0.15 meters. So that is L value here. So the Grashof will vary now. So again, you have to find out the value of Grashof. Grashof is equal to G beta delta T into L cube by mu square. That is equal to 9.81 into the beta is 1 by 60 plus 273 plus the delta. So plus it's into the delta T is T wall is 90 and T infinity is 30. It's not 60. Into the L cube is 0.15 cube by what is the new value that we have got previously? New value is 1.97, 18.97 10 to the power of minus 6. 18.97 into 10 to the power of minus 6 whole square. That is a Grashof. Tell me what is the Grashof value. Also, you'll take Prandtl here. Prandtl is 0.696. Am I right? Prandtl is 0.696. Yeah. So tell me what is Grashof. Fast. The previous thing, L will vary here compared
One,
to your
16577
167.
165.
Am I right?
351.25.
37 kada.
కాదు సార్
351.25.
25.
Okay. So tell me what is the product of Grashof into Prandtl.
0.15 into 10 power 8.
0.15 into 10 to the power of 8.
115.
115 into 10 to the power of 8. Is it?
Yes, sir.
Yeah. So Grashof into Prandtl is less than 10 to the power of 9 anyways. So if this is the case, so here in the range given to you, which one will you take? See, it is majorly falling in which range? Here 2 into 10 to the power of 4 you have, and 10 to the power of 6 you have here, and the power of 6 to 10 to the power of 11 you have. So yours is 10 to the power of what? 8. Since the 10 to the power of 8 is falling here, what you will do is, this is the range in which it is falling. So you make use of this one. And asal is equal to 0.15. Page number 144, 2.151 based on range. See, when the upper one is valid as here, for 8, so the second one only is valid. So the NU is equal to 0.15 into the Grashof into Prandtl equal to the power of 0.33. Okay.
Nusselt 33.67.
You substituted 33 point, tell me,
67.
67. 67, that is your Nusselt number value. So what you need is H. So you do HL by K is equal to 33.67. H into L is 0.15 now. The K value is 0.02896. Am I correct? K value is 0.02896. So this is equal to 33.67. You'll get H value. What is it?
6.50.
6.50 watt per meter square Kelvin. This is your H value. Based on this, actually, you have to get the value of Q actually. So how do you get Q here? Q is equal to H into A into T wall minus T infinity. So that is equal to the H value is 6.50 into A is 0.6 into 0.6 into the T wall is 90 and T infinity is 30.
140.4.
140.4.
Yes, sir.
0.4 watts. This is a Q value. So we're done with Q in question B. Okay. The question B is horizontal and uh, hot surface is facing upward. Hot surface is facing up. Here, hot surface is up. See, one more thing is it can be given like our cool surface down also can be given. Both are same actually. Cool surface down, both are same. Same formula, same procedure will be there. Even in data book, you can cross refer. Here, if the upper surface is heated, lower surface is cooled. Okay, both are same. Okay. In the next case, you see upper surface is cooled, lower surface heated. Okay. So this is how we will take. Okay. So for question C, this is the formula to be taken. So let's move to question C. Question C, write it here itself. For this, the Grashof and Prandtl remains the same. So we can use this space for that. Question C. The NU is equal to 0.27 into Grashof into Prandtl power. What is given there? 0.25 is given.
15.7.
The Nusselt number you're saying directly.
Yes, sir.
Am I right? Yeah, 15.7 is your muscle number. Good. And what is the other thing you need here? HL by K is equal to 15.7. H value is unknown here. The L value is 0.15, 0.0896 is equal to 15
3.03.
points. H is equal to 3.031 meter square Kelvin.
Sir, which
So,
matchup into candle number we should take, sir?
which one will you take? You
First
tell
or
me. The second one only you have to take because here in data book, this instruction is valid. L is equal to this one is valid for the horizontal plate. So since it is horizontal here also, you will make use of that L only. The second one you have to make use of. Is that clear?
yes, sir.
Yeah. Thank you. So now H is clear. So you have to get the value of Q here. Q is equal to H into A into delta T. So that is 3.03 into 0.6 into 0.6 into the 90 minus 30. Tell me what is this Q value?
65.
65.4.
65.4 watts. So that's the Q value here. So the thing is here, what we're doing, we are actually calculating the H values and Q values in various cases. So these H values and Q values will vary from case to case. So especially in the case of this uh, facing up and facing down, the Q value will vary hugely. Okay, what is the Q value? Here it is 140 and here it is 65, almost half down. Okay, so what is the meaning of it? When the surface is up, the heat transfer will be more. When the surface is faced down, the heat transfer will be very less. So while designing your components, especially these electronic components for your laptops and computers, so the kind of orientation that you put for this kind of natural convection case will hugely influence the heat that is coming into the plate. So that's why it is always advisable to keep the hot surface in the downward direction. So the heat transfer is actually very less compared to your hot surface up case. Okay. So how about your vertical case? Vertical case is again more. Okay. If you look at the vertical case, what is the Q value that you got? It is again 117. Okay, it is again greater than your 60. It's almost double to your 60. So among these three cases, the best case is your horizontally downward case, which will actually result in less heat transfer. Right? So let's move to the next problem. We're done with that. The next problem is here. So here you have one more problem. This is again a different kind of case. So what you have here is a 6 meter long and 8 centimeter diameter, 8 centimeter, 6 meter horizontal hot water pipe as shown in figure. So hot water is flowing through this one, and this particular tube is in a room, and the large room whose temperature is 70 degrees centigrade. The surface temperature of the pipe is 70 degrees. If that is the case, he's asking you to find what is the Q. The question he has given clearly that it is natural convection problem. So, what is the material you have here? Is it air or water? Somebody tell me. What is the material here? Yes, please respond.
Water.
Air is the material here. See, when it comes to natural convection, air is the thing that is coming into play. Water is inside. Okay. Here you cannot have the natural convection happening. There you will have forced convection. As the water is flowing, it is a forced convection example. So he is not interested in the forced convection. He is interested in the natural convection as a problem. So outside air is there. With air only natural convection will happen. So this is the tricky thing in this question. So it's not the water. The material is air. Very important thing. You may confuse with this. So kindly note this very clearly. The material is air and it is not water. Okay, you should take the properties of air. Right. So it's a natural convection. And in natural convection, which is convection of horizontal pipe case. And then the rest things are given here. Let me write those things. Given the given things are like the diameter is 8 centimeter and the length is 6 meter. And what else is given in the question? Temperature is 20 degrees centigrade and T wall is 70 degrees centigrade. So that's it. He's asking you to find out the Q value. How do you go about finding the Q value? You have to actually have the value of H with you. Okay. So before we go to that, we should actually have the we'll add this text also here. The properties are to be evaluated. The TF value. The TF value is T wall plus T by 2, that is 70 plus 20 by 2, that is 90 by 2, it is 45 degrees centigrade. So properties are to be evaluated. This properties here 45 degrees centigrade. So keep that aside and you have to check out whether this is a laminar or turbulent flow. So that is one thing. And you move to the formulas in the data book. They are here for horizontal pipes. See, you can see the horizontal cylinder, horizontal pipe kind of thing. Okay. So you can use any formula given to you here. Basically, you have to find the Grashof into Prandtl and in which range it is falling from the appropriate range. You will choose appropriate C here and EM here. So then it will solve it. This is a one way of solving it. But generally, this is taken for long, very long cylinders. Okay. And here we have one more formula. This is the first one. This whole thing you have to take. This is the second one. So based on your the shaft range, you will actually choose. Okay. So these are the formulas for the horizontal cylinders thing. So here, laminar or turbulent is not explicitly required because this is a special case of thing. So we can skip this part. So laminar or turbulent, I will not write here, but I'll directly take one formula here for finding out your Grashof and Prandtl. So Grashof is d beta delta t into L cube by mu square. See here, can I use L or D?
B.
See, here it should be used as a D. See, Grashof, the subscript it is given as D. Okay, this is a special case, Grashof subscript D. Grashof subscript D. What is Grashof subscript D means? Based on the diameter. Okay, it's given data clearly. So you should not put L here. You should actually put the diameter. So this should be diameter. Okay, so that is equal to the G value is 9.81 and the beta is 1 by TF 1 by 45 plus 273. The T wall is what is given in problem 70 and T infinity is 20 and the D value, what is the D value given 8 centimeter dia 8 into 10 to the power of minus 2 whole square by the new square you have to get from the data book. So for getting new actually to do the interpolation. Okay, 40
17.455.
for 45 here. See, the value is not there directly. So simply 40 plus 50 by 2 is 45. So you can take the average of these two and tell the value. Somebody telling it, tell me. What is it? New.
17.455.
17.45 into 10 to the power of minus 6 meters square per second. Substitute that 17.45 to 10 to the power of minus 6 whole square. Square is very important here. See,
Two
d
five
cube
nine
here.
three five.
This is d cube. I have made a mistake here. 8 into 10 to the power of minus 2 whole cube. You have to take actually. So tell me what is the Grashof value?
2593528.29.
Am I right?
Yes, sir.
Right. Grashof is done. Then what is required is Prandtl. So from the data book, you have to get the value of per Prandtl also. So here it is.
0.6985, sir.
Yeah, 0.6985. 6985 is your Prandtl. So you're having the Grashof into the Grashof and Prandtl. You have to have the Grashof and Grashof into the Prandtl.
1811579.5.
1
5
1
79.5.
0.5. So if I have to take the range here, 1, 2, 3, 4, 5, 6. So it is equal to 1.8 into 10 to the power of 6. Isn't it? The pressure into candle is in this one 1.8 into 10 to the power of 6. So here, in which range it will fall? It will fall in this range. Okay. Change the color. Here it will fall. So what you have to do, you have to choose this point 0.48 and 0.25 and solve it. The muscle is equal to page 146 you write and 3.1 you write. C into GRD into random. The
17
0.48 into the 1.81. 181 value, 10 power of 6 so the power 10 and the m is 0.25. So NU you are telling us? Yes, what is this NU?
17.6.
17.6 is your NU value. So now that you got it. So HD by K should be taken here. This is very important. Okay, again, this is NU with respect to D only. 100.6. So H is unknown here. H into the D value is 0.8 centimeters, 8 into 10 to the power of minus 2. The K value for air at 45.
0.02791.
Have to get it from this one. 0.02
781. 9191.
7
2791.
9.
H 6.14.
H is equal to 6.14 watt per meter square Kelvin. Put this one also in the box. And NU also you put it in the box. And what else I need? Q is actually asking you to find in this problem. So Q is equal to H into A into T wall minus T infinity. So H just now we have found out the H value is 6.14. T wall is given as 70 in the question. T infinity is given as 20 in the question. So what about area here?
Pi d.
Here you have to use the area with which the fluid is interacting. Area with which the fluid is interacting in this case is outer thing, that is pi d L. So pi d L in this question. D is given to you, it is 8 centimeters. L is given to you. What is this value given?
462.94 cube.
6 meters.
6 meters. So the Q value is 460. Yeah? Somebody is saying Q
463.1.
463.1 watts. So that's yeah, Q value. So you get Q. So this is one way of doing it. There is another way of doing it also. So for that, you can use page number 146. 3.2 formula also. You solve it. 3.2 formula is here. Okay, this one you can use or this one you can use. Both also you can use and solve it. Otherwise, you'll get the same kind of answers in both the cases. So that's all for today.